This is our intro video to ratio and proportion. So, for example, this says if a juice blend requires 1 cup of juice, concentrate, and then 3 cups of water, this would be considered a 1:3 ratio if you're talking about juice to water, or a 3:1 ratio if you are talking about water to juice. So it could be 1:3 or 3:1 just based on how you're relating juice to water or water to juice. Could be the same thing. So what this means is I want to make juice. I need 1 cup of concentrate and 3 cups of water. I mix them together and I get a full pitcher of juice. But what if we needed to make a double batch? Well, what you do is you would make 1 batch, which takes 1 cup and 3 cups, and then you'd make a second cup, or a second batch was 1 cup of juice, 3 cups of water, and you can see in total we now have 2 cups of juice and 6 cups of water. So again, this would be a 2:6 ratio, 2 cups of juice to 6 cups of water. Or a triple batch. You want to make 3 batches. There's 1, there's 2, there's 3. This would now require 3 cups of juice and 9 cups of water, so this would be a 3:9 ratio. But whether I am drinking the juice here, or here, all of the juices should taste the same because all of these are actually the same ratio. The proportion of juice to water is the same, even if I am making more or less of it. So, because of this, it is very, very, very common to use fractions when doing ratio and proportion. 1/3 is equal to 2/6 is equal to 3/9. These are all equivalent fractions, and these are all equivalent ratios. This would say if we have 1 cup of juice to 3 cups of water, if we double the number of juices and we double the number of waters, we should have something which tastes the same. Or if we triple the amount of juice and we triple the amount of water, again, we should have something which tastes the same. So, because when I double or triple a batch, I have to double the juice and double the water, it is very common for equivalent fractions because when we come up with equivalent fractions, we multiply top and bottom of the fraction by the same number. Doubling, tripling, whatever. But you need to watch the meaning of fractions. For example, 1/3. This does not mean 1/3 of my juice is the juice concentrate. If we come back up here, we can see we have 1 cup of juice and 3 cups of water. And if we were to add those all together, we would have 4 total cups. So actually, 1/4 of the whole juice mixture is concentrate and 3/4 is water. So you just need to pay attention to what the fraction actually is saying. And it is not saying 1/3 of our mixture is the juice. Rather, it could be saying the amount of juice concentrate we have is 1/3 the amount of water we have. So as long as you pay attention specifically to what you're saying, so if the water is 3 cups, this would be equivalent to 1/3 the amount of this, but not 1/3 of the total juice. So just something to watch as we move forward. Now, this isn't a problem out of activity 7A. This is a red punch and lemon lime soda problem where they're mixing red punch and lemon lime soda to come up with some sort of fruit punch drink. And mixture A takes 1 cup of red punch and 3 cups of soda, and that is a total of 4 cups of fluid. And so again, you could look at these things, right? 1/3. These are actually the same numbers we just had where I had like 1 cup of juice and 3 cups of water. So you could think of this as a 1:3 ratio here, or a 1:4 ratio if you want to think about it that way. But this would say 1/4 of the juice is the red punch, or the amount of red punch is 1/3 the amount of lemon lime soda. Just need to be very careful with what we are trying to say. All right. Now this says we want to come up with mixtures that taste the same. So the proportion of red punch to lemon lime juice needs to be the same proportion. So we want the flavors to be the same. We don't want it more juicy or more soda-y. And so the easiest way to do it as a start is, well, if I wanted to double the red punch, turn my 1 cup into 2 cups, well then I would double this and make this a 6. And if I have 2 cups and 6 cups, well, you put those together and that would double the total cups to 8 cups. Or if I wanted to use 9 cups, right? If I wanted to use 9 cups of lemon lime juice, well, that would triple this, which means I would need to triple this, and that would eventually triple this, right? 3 times 4 is 12. It's the same thing. 3 plus 9 is 12. But this also works if we want to cut things in half. So these are just possible mixtures that taste the same. Say I had 2 cups here. Well, that is half of this, which means I would need half of this, and I would also need half of this. And hopefully 1/2 plus 3/2 is 2. All right, let's just erase some of these arrows. Now, something which is often helpful is to come up with unit relationships. So we already have here 1 cup of red juice, and then these are what you need with 1 cup of red juice. But what if I needed 1 cup of lemon lime soda? Well, this is a third of this thing, so I would need a third of this thing, which would be 1/3, and I would need a third of this thing, which would be 4/3. And then again, hopefully 1 plus 1/3 would equal 4/3. Or I could even come up with unit values over here. Like, what if I just said I wanted 1 cup total juice? Well, this was a fourth of that, right? Take a fourth of 4. So I need a fourth of the 3, which would be 3/4. And I would need a fourth of the 1, which would be 1/4. And so we can scale up or down our recipe as needed. Now, this is a different one. It says, let's come up with mixtures that taste the same as mixture B. So you can always say, well, let's double this, and let's double this. And again, hopefully this plus this also equals this. Otherwise, this context doesn't make sense. Now, what if I wanted to make 2 cups or use 2 cups of red punch? So we'll get there in a minute, because sometimes you have to say, well, what would I have to do to a 3 to make it a 2? And there's oftentimes an intermediate step, which is, what do you do to a 3 to make it a 1? 1 is 1/3 of 3. So what is a third of 5? 5/3. What is a third of 8? 8/3. And now we've come up with the unit value, so I know how much of these relate to one of these. And so now if I actually wanted, let's get rid of those, 2 cups, well, I simply have to double this one, which means I can double this one and have 10/3, and double this one and get 16/3. Which is why these unit values are nice and easy to work with, because they help you get other things that are not so easy. So if I wanted, or if I only had a cup of lemon lime juice, well, that's 1/5 of this. So I would need a 1/5 of this, which would be 3/5. And I would need a 1/5 of this, which is 8/5. Or if I just wanted 1 cup total, well, that is 1/8 of this. So I would need 1/8 of this for 5/8, and 1/8 of this for 3/8. All right. Moving on to a couple other problems. So this is a proportional problem done on a double number line. This says if 3 yards of rope weigh 2 pounds, then let's find the following lengths and weights of rope. And so 3 yards weighs 2 pounds. We can say 6 yards is 4 pounds. Add on another 3 yards, add on another 2 pounds, another 3 yards, another 2 pounds, another 3 yards, another 2 pounds, another 3 yards, another 2 pounds. So if I wanted 18 yards, that would weigh 12 pounds. But 16 yards and 14 yards, 16 would be right here, 14 would be right here. They don't fall on one of these exact values. So this is, again, is an example of where I would scale it back. So I'm not going to do 14 at the moment. I'm just going to look at 16. So what I would want to do is scale this down. If I just wanted 1 yard, well, I would need to take, a third of 3 yards. So the weight would have to be a third of 2 pounds, which would be 2/3 pounds. So I have 10 pounds to get me to 15 yards. So if I wanted 1 more yard, that would need 2/3 more pounds. So this would be 10 2/3 pounds is how much 16 yards would weigh. And again, the strategy is by scaling down to a unit value. All right, so let's look at this next one that we're going to take a look at. Number 3. It says a scooter goes 3/4 of a mile in 4 minutes. How far does the scooter go in 12 minutes? Well, we could do what? Minutes and distance. And so we already know that in 4 minutes we go 3/4 of a mile, so double that. 8 minutes is double this, 6/4. Add on another 4 minutes, so that's 12. Add on another 3/4, and we have 9/4. So we can work up like that. And if I went on another 4, that would be 16 minutes, and that would then be what, 12/4. But so this is a table method, but it's the same stuff as the double number line, right? But what if I wanted 17? Well, that is not another 4 minutes, so I cannot add on another 3/4 mile, which means I would need to come up with the unit value in 1 minute. So 1 minute is 1/4 of 4 minutes, so I would need 1/4 of 3/4, right? The assumption is the speed is the same. So if you double the time, you double the distance. You triple the time, you triple the distance. You cut the time in half, you cut the distance in half. You cut the time in 1/4, you cut the distance in 1/4. So what is 1/4 of 3/4? Well, 1/4 times 3/4 should be 3/16. So if I wanted to know how far I went in 17 minutes, well, I would need to take my previous distance here and then add on 3/16, the amount of time, or the distance we would go in 1 minute. And again, you could combine those to figure it out. All right, scrolling on to the next one. This is part of activity 7C. Using strip diagrams, which is really, really similar to what I did up here at the beginning. You know, these things, if I put them together, would look like a strip diagram. So this problem says we are making green paint. We mix blue paint with yellow paint, and we get green paint, and the mixture is a ratio of 2 to 3, 2 blues to 3 yellows. Now, this first problem says if we use 26 pails of blue paint, well then how many pails of yellow paint would we need? So that means all of this is 26 pails of blue. So cut 26 in half, and that means this is 13 and 13. And if we're going to maintain this ratio, this has to be 13, 13, and 13. So 13 plus 13 plus 13 means we would need 39 pails of yellow to maintain our 2 to 3 relationship with 26 pails of blue. Now, this one says, but what if we wanted to make 125 pails total of green? So the 125 pails is not the amount of blue or the yellow, but when we put it all together. Well, if you put your blue together and your yellow together, you might see we have 2 parts to 3 parts, which makes 5 total parts. So if I take 125 and I divide it by 5, I should get 25, which means this has to be 25, 25, 25, 25, and 25. So I would need 50 pails of blue, 75 pails of yellow to maintain a 2 to 3 proportion and end up with 125 total pails. All right, last problems. 7E, number 1. So again, I'm going to use strip diagram methods. It says at lunch, people could choose pizza or hot dogs. And it says the number of students that wanted pizza was 3 times the number of students that wanted hot dogs. But altogether, if 160 students got lunch, how many got pizza and how many got hot dogs? So that says all of this together, these 4 pieces makes up 160 students. So if you take 160, you divide it by 4, you should get 40, which means this has to be 40, 40, 40, 40, and 40. So I would say 120 students got pizza and 40 students had hot dogs. And then hopefully we can see, you add those together, you get 160, and the pizza is 3 times the amount of students that got hot dogs. Last example, and then I will stop this video. This says Shantae and Jessica have cards, and Shantae's cards is more than Jessica's by a ratio of 5 to 3. So if here's Shantae's cards, her ratio would be 5 to 3 of Jessica's. But then it says, after Shantae gave Jessica 15 cards, both girls had the same number of cards. How many cards do they each have now? So for them both to be the same, let's see. if she were to take this piece over here at the end and move that down over here, they would both have the same. And it said she gave her 15 cards, so this has to represent 15 cards, which means every single one of these has 15 cards. And now we can go back and answer our question, how many do they each have now? And the answer is 4 groups of 15, which is 60. And you could then work back to the beginning of the problem and say, well, this is how many Shantae had to begin with and Jessica had to begin with, and we could verify a 5-to-3 ratio. But that is just an intro to some of these problems.